Hello and welcome back to DevDive. In today's episode of Deep Dive into Hibernate and JPA, we're going to delve into Hibernate architecture, and just after that, we're gonna get our hands dirty by setting up our first project. Alright, let's dive in right after the intro video. Hibernate is an ambitious project that aims to provide a complete solution to the problem of managing persistent data in Java. Today, Hibernate is not only an ORM service, but also a collection of data management tools. And the Hibernate project suite includes the Hibernate ORM, which is the core of the framework. It provides also a base service for persistence with SQL databases. But the most interesting feature is that this particular module is framework independent. It means that we can use it on its own or in any runtime environment with all GGKs. The next Hibernate's module is the Hibernate Entity Manager, which is a Hibernate implementation of the standard Java persistent APIs. It's an optional module, and to be more specific, we'll be using the Entity Manager interface to persist, retrieve, or update data in the database. And this is the beauty of JPA, because we'll not be using the native methods of Hibernate. For the validation, Hibernate uses the Hibernate Validator module, which is an implementation of the Bean Validation GSR 303 specification. It's also independent of other Hibernate projects, and it provides declarative validation for your domain module. As you can see in the example, we can specify if a property is not null, or whether the size is in a range, or if the field also match a certain pattern. Hibernate includes some additional modules like Hibernate Inverse, which is a module dedicated to audit logging and keeping multiple versions of data in your SQL database. Hibernate Search, used to push data in a remote Elasticsearch indexes. And Hibernate OGM, which is a module that provides JPA support for NoSQL solutions like graph-oriented, document, or key-value data stores. One last thing before diving in the code is the JPA persistence unit. Actually, a persistence unit is a pairing of your domain model class mappings with a database connection, plus some other configuration settings. Every application has at least one persistence unit, and some applications have several if they're talking to multiple databases. Hence, in our project, we'll be configuring one persistence unit since we're using a MySQL database. So let's investigate the configuration. The standard configuration file for persistence units is located on the class path in folder, and more precisely in the persistence.xaml file. This allows the JPA provider, in this case Hibernate, to find and load the configuration information specified in this file during runtime. The persistence.xaml file configures at least one persistence unit, and each unit must have a unique name. In this file, we should also specify the provider, which is the JPA implementation, and in this case, since we're using Hibernate, we're gonna use the org.hibernate.jpa.hibernate persistence provider. Standard or vendor-specific options can be set as properties on a persistence unit. Any standard properties have the javax.persistence name prefix. In this case, it's Hibernate. As you can see, we're specifying the connection URL so we can talk with our database. We're providing also the username and password of the user we're gonna use. The driver class is configured to indicate the use of JDBC driver, and we're setting dialect to allow Hibernate generate SQL optimized queries for our database. And to make sure we're not gonna lose our data in every application start, we're setting the Hibernate DDL auto to update. So now, since we're familiar with all of these concepts, we're gonna create a project and configure Hibernate in JPA. Follow along with me, and of course, if you have questions, leave them in the comment section. The code will be uploaded in a GitHub repository, and the link will be in the description. So without further ado, let's get started. So I created a basic Maven project Hibernate demo using the quick start archetype and in the pom.xml I'm specifying the dependencies we're gonna use. So the first dependency needed is the Hibernate core, which includes the entity manager. We'll add the Hibernate validations also, and since we're not operating within a container, it's important to include the Hibernate validator CGI dependency along with the expression language. It's worth noting that we're now using Jakarta, so we will observe that all imports will originate from Jakarta rather than JavaX. The second thing to do is to create a Docker Compose file to start our database. As you can see, I use the MySQL image. If you want a detailed course about Docker Compose, just leave it in the comment section. So here I'm specifying the port and environment variables so I can create a user, password, and database name. I created also a volume to bind the data inside my container with my local machine. So now, since we're having our database, let's configure our persistence.xml file. We've already seen the configuration. We're just gonna specify the persistence unit name, the provider, and different properties. And to use the database, we're just gonna copy and paste the database name from the Docker Compose file. So in order to load the configuration from the persistence.xml file, an entity manager factory is needed. So the next step is to create an entity factory builder to make sure that we will have a single instance of the entity manager factory. It's basically the singleton pattern. It means a private constructor is needed. We'll be creating a public static method to get the instance. This method will check if the entity manager factory is null. If it's the case, we will call the create entity manager factory method and give it the persistence unit name as an argument. It's more cleaner to create a separate variable using the static and final keyword, and to make sure we will get the right persistence name is copied from the persistence XML. Otherwise, if the instance of entity manager factory is not null, we're just gonna return it. In our main method, we will call the get entity manager factory method and get the entity manager using the create entity manager. We will need a transaction so we can interact with the database and roll back whenever something bad happened, or just commit our code if everything goes well. So before starting to save our entities in the database, let's make sure our database is running. And to do that, we're gonna start our Docker Compose service and check if the container was created using the docker ps command. So since everything is running, let's create our first entity message. So we're gonna create a new class message and annotate it with the add entity annotation. So Hibernate maps this class to a table called message. The message entity must also have an identifier attribute annotated with the @id, so Hibernate can map this attribute to a column named id. And obviously someone must generate identifier values, and using the generated value, it enables automatic generation of IDs. So now let's try to save some entities. So to get started, we're gonna create a try catch block so we can roll back our transaction if something goes wrong. So in order to start, we're gonna begin a transaction using the transaction object, and then we're gonna write our logic, and then we should commit our code to publish the changes in the database. And as I said, in the catch block, we're gonna do a transaction that rollback. So the first thing is we should create a message object, and then we should set the text. So we're just gonna write test text. So that's it, and then we're gonna call the entity manager to save the entity in the database using the persist method. So that's it, we're gonna run our application, and as you can see, everything is going well. Okay, So we're gonna open our console and show tables, and as you can see, the message and message stick tables were created. The message stick is used to generate IGs, and we're gonna see that in more details later. So here we're trying to fetch the messages, but it's not gonna work because we didn't use the Shopix database. So first we will show the databases in our server and use the Shopix store database. So now we're gonna execute another query, and as you can see, it's working without any problem. So that's it for this video. I hope it was helpful. In the next video, we're gonna explore the auction project class diagram so we can start implementing all of its entities. Thank you guys for watching. Take care, and I will see you in the next one.